Hello, everyone, and thank you for joining me in this session today, where we will give an overview on GitLab Operator for OpenShift and Kubernetes. My name is Samir Akub. I'm Solution Architect with GitLab based in Melbourne, Australia. These are my contacts. Please feel free to reach out if required. So what we will cover today, an overview on the Kubernetes controllers, as well as overview on Kubernetes Kubernetes operators, installation, how to install GitLab Kubernetes operators, and a bit of overview on the Kubernetes operator maturity model and what we should be concerned about when deleting GitLab Kubernetes operator. So before diving into the Kubernetes operator, I thought we should start from the Kubernetes controllers, because I think of them as the simpler version of the operators. So as we all know, in GitLab, Kubernetes in general consists of objects. Deployments are objects, pods are objects, replication controllers, services, ingress. Everything almost in the Kubernetes cluster is represented as an object. Well, each of these objects and their spec field and the definition of the object, they have a definition of their desired state. As some of you who maybe has worked with deployments, for example, in a deployment, I declare what are the replicas, number of pods I want to have inside that deployment. As in our example here on the right, down here, you'll see like, okay, I have three pods. The controller job is basically, as a controller, is to keep on comparing that object spec field, which represents the desired state, and the actual state of that object inside the Kubernetes cluster, right? And if there is like any inconsistency between the two, the controller job is to change the current state to make it as close as possible to the desired state. Of course, practically under the hood, everything goes through the other components like the Kubernetes API server, the scheduler, who's responsible for scheduling these pods, everything. But on an abstract level, this is what's happening. So if a user in our example here add a new pod, say, okay, I'm a user, I'm changing my deployment object definition, and in the spec, I'm saying, okay, please kubectl scale my deployment and add a new pod. The deployment controller, because it's continuously comparing the desired to the current state, will update the current state and add a new pod. Same if the desired state of that object changes by removing a pod or adding a service or whatever, right? So this way, the way controllers control the objects is perfect for stateless applications or stateless objects, because it is really as simple as delete, add, or change the status of the pod. There is no application context here, right? It is just changing the implementation of that Kubernetes object inside cluster. Well, what if I have stateful applications, where I need to have more of an application knowledge to properly control and operate that object? What if I'm doing this for a database? How will I define for the controller that, please, when you add a new database instance or pod, please redeploy or redistribute the data between the three instances, or keep certain number of pods running between the databases and elect one of them as the master node, or maybe take a backup overnight from that specific database constructs outside as operating it, or maybe monitor the database, let's say KPIs, and change or scale horizontally and vertically as per the workload inside the database. This is exactly where the Kubernetes operator come in the picture. Well, basically, think of the operators. I really like this picture. Think of them as exactly these robots. I am basically, it was introduced in 2016. And basically, it's a great way for managing Kubernetes applications, especially, as I said, stateful applications. Think of them as an automated SRE or site reliability engineer for the application. It's beyond the day zero and day one only tasks for deploying the application. It's all about all the other tasks that SRE is responsible to do on the application to keep it running, which are more related to the application context or application logic itself. And that same applies to the GitLab Kubernetes operator. So in other words, the ultimate objective for the GitLab Kubernetes operator is to take care for deploying, upgrading, and the operation of the GitLab deployed instance, from backup, recovery, from monitoring, from scalability, whether horizontally or vertically based on the KPIs defined as an object or as an application level. So the operator comes really with what we call custom resource definition. So if I go back just 2 slides here, this, we agreed that the objects in Kubernetes are defined, or every component in Kubernetes is defined an object. So deployments are objects. So when we say custom resource definitions, think of them as an extension to these objects. Basically, I am defining a new kits inside the Kubernetes cluster, but these are my own defined objects or custom defined objects. That's why it's called, sorry, it says there customer, it's custom, sorry, it's custom resource definitions. So the operator basically it does 2 things. First, it extends the Kubernetes API by adding custom resources. So the API is used to the normal resources, deployments, pods, services, ingress. These are normal built-in, out-of-the-box available resources. Excellent. With the CR or the custom resources, I am defining, or using the CRDs, the custom resource definition, I am defining new resources to the API server. Say, Mr. API server, would you please also, can I introduce you to a new kit in your farm, which is, let's say, GitLab. GitLab will become as an object similar to the deployment object, similar to the pods object, similar to the services. Along with a control plan, and this is a sort of a controller similar behavior, let's say, a control plan component that monitors and maintains the resources of the new type, right? So this is the command and control, the brain for the operator. This is the operator itself, which is this box here. So 2 things, a new resource defined using the custom resource definition. In our instance, the new resource is GitLab, and a new a controller for controlling this resource, which will cover the full life cycle for that resource, which we'll see in a second. So why we should care about GitLab Kubernetes operators? Basically, GitLab Kubernetes operators, let's say the key trigger for them was for deploying GitLab to against OpenShift, right? Today, an operator already available and ready to use for use and to be utilized in OpenShift operator lifecycle manager for GitLab runner, where basically I can deploy GitLab operator and I can define GitLab, I can deploy GitLab runner operator, and I can define GitLab runner custom resource using custom resource definition, and within the OpenShift Kubernetes cluster, so that the operator or GitLab runner operator will be responsible for deploying and managing the GitLab runners. And this is available today. What GitLab added recently, it's still up to the recording of this video, which is 26th of July. It is in beta, but you can start using and at least testing it, not in production ready yet, but you can at least have a taste of it. Within GitLab, within the OpenShift Kubernetes cluster, and as I will show you in the demo in a bit, within any Kubernetes, cluster, which is the GitLab operator for Kubernetes. This operator is for the GitLab server itself, for the components of the GitLab. And in this instance, it comes with a GitLab custom resource definition for the defining the GitLab as a whole as one object, where I can instantiate GitLab object, and the operator will be responsible for managing, or the GitLab operator will be responsible for managing the whole life cycle of the GitLab object. So just to summarize here, GitLab operators in general are components within introduced in the Kubernetes cluster for managing mainly stateful applications. And why they were introduced? They were introduced because we are trying to automate the SRE, or the site reliability engineer, daily tasks for managing applications. So by adding an extra layer of automation, which is not only what the controller is doing under the hood, it is the next level where you are adding business logic oriented, specific for the application to manage the application. How's that done? Two things: defining the custom resource, which is based on the custom resource definition, which is based, you are introducing a new object definition within the Kubernetes cluster, along with the operator for controlling that custom resource lifecycle. Today, GitLab is providing two types of operators. One is already production ready and can be used as of today, which is the GitLab runner operator, available today in the operators manager in OpenShift, and even can be deployed outside OpenShift, and as well as the GitLab operator itself, like the GitLab itself operator, or GitLab operator as we call it. And this is used to deploy GitLab itself within the GitLab, the Kubernetes cluster, including the OpenShift. Good. So what does it mean to deploy or installing GitLab Kubernetes operator? First, let me highlight one thing here. Or maybe I should. Okay. Let me say, before I go into the details, the GitLab runner operator is already available. The GitLab operator, which is today is beta, it depends on where you are installing it. The steps I'll show you in a second can be used to deploy that operator on any Kubernetes cluster, vanilla one, or even if you are going direct against OpenShift. But in OpenShift, you have an out of the box, using the UI, using OpenShift lifecycle, the operator lifecycle manager in OpenShift, it can handle the complete deployment of the GitLab operator. Basically, you don't have to go through like the manifest way of manual deployment of the operator, which I will show you in a second. But it's good to understand what's happening under the hood, and it's good. It's also, you can use that to deploy the operator to a Kubernetes cluster outside OpenShift, at least for testing purposes. So basically, the steps are simple. Deploy the operator lifecycle management. It's really optional. It's for managing the operator's lifecycle itself, a component that can make the management of the operators much easier. Again, install Nginx controller. The GitLab operator itself comes with a default Nginx for deployment, or you can use your own Nginx controller if you decide to do that. And it's easy to point the operator to use that Nginx when creating the GitLab custom resource. Install the matrices server, which will be responsible for collecting the utilizations from the underlying GitLab, Kubernetes cluster, and feed that into the operator in order to make operation decisions for the GitLab custom resource in terms of scalability, horizontal or vertical. A main step, number 4, install GitLab custom resource definition. And this is exactly where you say, Mr. GitLab, Mr. Kubernetes, by the way, here is a definition for the Kubernetes a new object or custom resource, new object, which is in our case GitLab. So next time when I use a kind GitLab, you know what I mean, right? So again, Kubernetes already has definition for other default objects like deployments, ingress, pods, resource controllers, and other objects. In this step number 4, I am introducing a new definition into the Kubernetes library. In our case, it's called GitLab. So next time I can create a new object, open a new manifest, and in the kind field, I say GitLab. That's it. And Kubernetes will understand, okay, I know what you mean because I have that definition in my library. And this is where you need to install. Then, of course, install the operator or the controller GitLab operator itself, which will basically take care of managing the components that you will, the objects you will instantiate out of the custom resource definition, which are the custom resources. And basically, at the end of the day, use that installed custom resource definition to create the custom resource or the GitLab custom resource. Once this is created, then you will get all the objects of the GitLab deployment and along with the controller manager. In this instance, this is exactly the controller we were talking about, but it is responsible for controlling the objects of the deployed GitLab object, the pods or the components of the deployed GitLab object, like GitLab web server, controller manager, manager task runner, and registry. So just to recap, the main things I want you to remember from this slide. You will need to deploy. There are some components which I would say helping or supporting components like Nginx, optional, operator lifecycle management, optional, certificate manager. You need it in order to generate all the required certificates for the communication between the operator and the API server, and but there are two main components here. The custom resource definition, which defines this new resource in the Kubernetes cluster, and the operator, which will be responsible for managing that resource in the Kubernetes cluster, of course, through the API server. I think we covered this one. So as I said earlier, in Kubernetes or Kubernetes operator, there is a defined operator maturity model, right? Which has 5 levels. Level 1, basically I'm using the operator to install the component. It is very similar to what we do today with other objects, deployments or services or any other objects. Basically, please, Mr. Operator, create for me a new object. It happened to be, in our case, GitLab new object. Second, use that operator to patch and minor version upgrade, right? So upgrade for me, and I'll show you that in the demo, upgrade for me GitLab from version like 10.34, I'm just making that up, into the 10.35, the next version. Now, from these two are supported using the Helm-based operator. And by the way, as of today, the GitLab operator is within that area. It is using Helm right? But it is moving or quickly moving beyond that to climb up the maturity model towards level 3, 4, 5. And this is where the nice magic, I would say, of the operator comes in the picture. Full lifecycle management, right? So not only install, not only deploy and manage, upgrade, but also please operator be responsible for backing up and failure recovery of my GitLab installed instance, right? Remember, today these tasks are done sort of manually or at least outside the deployment of the Kubernetes cluster. They are done using tasks maybe automated by the SREs. I'm bringing that within that object. So I am the operator, I am the GitLab operator. I know the GitLab object. I know how to back it up and fill it. When I move into the next maturity, I not only can back it up and fill it, but also I will be able to look into the matrices and alerts and logs coming from my GitLab server and be able to analyze that and maybe raise alerts or send notifications based on the status. So it goes into more of a preventive action based on the status on operation of my GitLab deployed object. Last one, autopilot. I can, as GitLab operator, I can scale horizontally and vertically by adding more pods or even more Kubernetes nodes to scale my deployment as per the workload, as per the thresholds defined in my deployment, right? So it's a full autopilot. So think of it when the operator is at level 5, you define the CRD, or you install the CRD, you install the operator, and again, if you are working on with an OpenShift, these two will be done, are automated or be provided using the operator manager in OpenShift. So you don't really need to go into these details. But even if you are installing the custom resource definition, the CRD, which defines the GitLab, you're installing the operator, and then that's it. You are creating a new GitLab object, have it deployed, which will be created within the Kubernetes cluster. And by GitLab object, under the hood, it has all the required capabilities and pods from the GitLab deployment. And then that operator will be responsible for deploying, upgrading, backing up and failure recovery, monitoring, as well as scalability up and down, horizontal and vertical scalability as per the workload. From levels 3 to 5, the operator will need to use either Ansible or Go to function these features. Again, to make it clear, up to the recording of up to the date of this recording, GitLab operator is using Helm charts so that it is supporting today level 1 and 2 of maybe partially level 2 of the maturity model. So deleting Kubernetes cluster, things, and I'm sure this list will maybe grow as we move forward with the GitLab operator development in GitLab, but it's important to remember that deleting the GitLab, these are the 3 steps, by the way, for deleting the GitLab operator. And I will show you in a second the repo where you will find all the instruction for installing and deleting the operator. It's very important to remember here that deleting the the custom resource definition and the operator does not delete the created namespace for GitLab and does not delete the persistence volumes or volume claims and secrets, so that the data itself for the deployed for the GitLab object is not lost after you delete the operator and the custom resource, which makes sense, right? You don't want to delete the object and delete the data. That data will be there. As I said in the second point, does not delete as well the namespace. Okay, cool. So let me switch quickly to the demo. So in my case here, you'll see that I have my GitLab. Sorry, if I do git kubectl git labs in my namespace. Okay, dun. Once I get the answer back. So I hope I will get the answer quick. Yep, here we go. I have a GitLab custom resource defined. This is my object. You see the command GitLab GitLabs. GitLabs is like I'm doing it as similar to the command git kubectl git deployment. That defined GitLabs, as you would imagine, is coming from the defined CRD. I have added a CRD there called GitLabs. It's already deployed as GitLabs for my deployment. So let's do one thing here. Let's go, I think in my case here, this is the repo. So if you just Google GitLab operator, this is the repo that has all the instructions for deploying, sorry, maybe, yep, you can have it here as well as, yep, this is the, okay, let me open this in a new tab. So, okay, cool. So what we can do here is, and by the way, there is a very nice article done on OpenShift, a blog on OpenShift for deploying, on Red Hat website for deploying GitLab operator for OpenShift. It has all the details along with a link for the installation instruction. So the article is test the new GitLab operator for OpenShift. It was really helpful, and there you will find a link to the deployment steps for deploying GitLab operator. And as it says here, GitLab operator can be deployed to manifest in Kubernetes or OpenShift. In my case, I try to do that simply in Kubernetes. It works perfectly well. Only thing you may find is in this step here when it says, let's say, I'll just take this. I just want to show you something. I go back to here and say the same command. Let's keep it running. Okay. Okay, I know it's already there. Cool. So you will have this error if you are deploying against Kubernetes, not OpenShift, because security context constraints are OpenShift specific objects. Don't worry about that one. Just continue and move forward. And thanks to our engineers in GitLab who helped me with this hint. So don't worry about this one if you are deploying. And in this step, just go ahead and go to the next step. So this repo will show you how to deploy the CRDs. It has all the required scripts, how to deploy the GitLab operator. And then this is the nice part, how to create a new object, which is the custom resource out of the deployed CRD. You see this one here? Actually, let me switch here. I have this file, which I used. You see this one? Kind here, it says GitLab. What is that? As you would imagine, this is the CRD defined for GitLab. And this is the name of the object, and the version. And this version 10.4 is the version of the Helm chart used for this deployment. As I said before, so far GitLab operator is using Helm chart. So if I go back to my repo, you will see that we have in the same repo, you will have a file called chart_versions, and these are the Helm chart versions. And to see the difference, if I go here and say GitLab Helm chart version mapping. Yep. So here's a mapping between the GitLab Helm chart and the GitLab version. So in our deployment here, you see that I am using 4.10.4, and the GitLab version on the right here If I go into here, removing the bookmarks, under version, the version deployed is 13.10.4. So if I go here is and search for that one. Okay. Yep, 13.10.4. So what I'll do is I'll go back here and say, okay, I'll take this one, 14.11.3 chart, which is in the mapping. Let me go back here. Yep, it's 14.11.3. So this should deploy the GitLab 14.11.3. So how I find this working is simply I go to kubectl underscore and then I will delete. Yep, I'll delete this. So I'm just deleting an object called GitLab, right? As you may remember or recall from the session, this will not delete the namespace and this will not delete the PVCs or the persistence volume claims or persistence volumes from my GitLab namespace, which is in my case GitLab system. And then I'll do like Vim, this one, go here and oh, sorry, I did not copy properly. Okay, so I'll just copy this one again. Come here, remove this one. Oh, okay, I'll just type it. What was that? 4.11.3, 4.11.3, and that's it. And then if I do kubectl get pods, get pods, from that, you see that all the pods have been deleted. Kubectl apply, sorry, not this, apply kubectl, apply, sorry, kubectl apply hyphen f, what was that? My GitLab, yep, YAML created. So now if I go back and say get pods hyphen, so now soon we should start seeing the pods of the GitLab created. So if I refresh here now, there is nothing because the GitLab has not been created. So hopefully soon we should start seeing the pods of the GitLab created because I created a new object of type GitLab, which is managed by the GitLab operator, which is installed in my Kubernetes cluster. So until this is created, let me just rehearse quickly what we have covered today. Basically, we started from the GitLab, from the Kubernetes controllers, and we agreed that Kubernetes is declarative based. Basically, you have an object. The object has a field in the spec which represents the desired value or the desired version of that. The desired status of that object, and the controller job is basically to continuously compare between that desired version or status and the current status of that object. And if they are different, then the controller will be responsible to bring the current state of the object as close as possible, if not the same, to the desired state. We agreed that controllers are doing excellent, awesome job with stateless applications. But when it comes to stateful applications like databases, like GitLab, it becomes extra tasks would be required in order to manage these applications because you have a level of business logic specific for the application for managing these deployment or these objects. Usually, traditionally, these tasks are done by the GitLab, by the SREs of that object. With the GitLab operator, with the operators in general, we are trying to abstract or move and automate these tasks and bring them more into the Kubernetes clusters. This is why GitLab has been developing GitLab operators for operating and installing GitLab in the Kubernetes clusters, and specifically for OpenShift deployment. Today, we have two types of operators: the runner operator for deploying GitLab runners in OpenShift. They are available. You can use them. They are available in the OpenShift operators library, as well as the newly introduced beta GitLab operators for OpenShift, which can be used to deploy GitLab against OpenShift cluster as well as Kubernetes cluster. Same as any other operator, we provide the CRD, custom resource definition, for the GitLab and the GitLab operator itself, and you can use them and test them to deploy that into the GitLab. I'm just trying to see if that, let me just check on that status there quickly before I conclude this one. Yep, so it is, the object is being created in the background. So hopefully at some point it will bring that object into the creation and will make it, it will be created. Yep, so you see here in the background the logs for the operator, and you see that it is trying to create the object, and yep, reconciling, updating, all of that. Yep, so it's being created. So okay, I won't keep you waiting, but this is the idea of the deployment, and yep, I hope that you find this useful. Thank you very much for watching.